Saxon Advanced Mathematics, Lesson 29. Students, buckle your seatbelts. We have an exciting lesson today. We're going to talk about something called quadrantal angles. It's an idea that we're going to build on and use quite a bit in the future. And so this is just the first step, and we're going to fill in and add more details to this concept as we go. What I want you to imagine is a circle. That's not so bad, right? And pretend it's perfect. We have our X and Y coordinates, and this circle is formed by taking a triangle with a hypotenuse of 1, okay? And imagine us taking this hypotenuse of 1 and swinging it all the way around so that the radius of the entire circle is always a 1, okay? It's what's called the unit circle. And we use this as an organizer for a lot of information about trigonometry, all right? And we're starting to build this unit circle in our minds. But what you just want to imagine is that we can move this radius anywhere on this circle and draw a triangle. And what we're gonna do in the future is we're gonna move this radius to some really useful places and memorize sine, cosine, and tangent at that location. Today, we're gonna focus on just the 4 extremes, the 4 quadrants, if you will, quadrantal, the angles at the quadrants, okay? Pretend this is perfect. It's not, okay? So what we're interested in today is what happens if you draw the triangle right here so that the hypotenuse is at 0 degrees. What happens if you draw it up here so that it's at 90 degrees? What happens if you do it over here at 180? And what happens if you do it down here at 270, okay? Now, here's the thing that I want to point out. This is kind of theoretical because the truth is that at 0 degrees, there is no triangle. It's a flat line. If you have 90 degrees, there is no triangle. It's a flat line. Same here, same here. So what we're talking about is the triangle that's just outside of that because we want to approach that extreme even though theoretically there's no triangle at it. So you have to kind of put your brain into a little bit of a fantastical place and go from there. So what I'm going to do is I'm going to redraw this already. First, I'm going to do this. I'm going to draw it this way first. Okay? This is my 1 unit out all the way around, right? Because my circle has a radius all the way around. And we're going to start right here at 0 degrees. Okay? Now, at 0 degrees, we can't, I'm going to move it up a little so you can see better. There is no triangle we can draw, but I'm going to draw one that's really, really close to 0, okay? It looks like that. Now, this triangle, we can imagine, it has an adjacent side, it has an opposite side, and it has a hypotenuse. Because of this unit circle, the way we've drawn it, our hypotenuse is always equal to 1. Okay, that's how we drew our circle, is by taking that hypotenuse and spinning it around. So our hypotenuse is always equal to 1. Sine, cosine, and tangent are the same as we've always done them. Sine is equal to Oscar had a hold over Arthur. But here's a cool thing. We can also find tangent by putting the sine over the cosine. If you play with the complex fraction that you get here, it works out. Let me just show you. If we take sine over cosine, that's OH over AH, right? Using these. Here, let me do it over here so you can see it better. Sine over cosine equals OH over AH. Complex fraction work, we multiply by the reciprocal. That goes to 1. The h's cancel. I think this is tangent. And so we get, all right, so this is a shorthand way to calculate our tangent. We can just find it as sine over cosine. See, I proved that it works. So what we can do is we can use this value to calculate tangent once we get sine and cosine. It just speeds up our calculations a little bit, all right? So what we're gonna do is we're gonna figure out what sine, cosine, and tangent would be at 0 degrees, okay? That's where we are starting here. Our hypotenuse is always equal to 1. This is at 0 degrees. And we're gonna work around and do each of the 4 quadrants, just so you know. At 0 degrees, the opposite side is going to be 0, right? It's very tiny here, but we can see that it would be 0 over 1. So the sine of 0 degrees is 0. Let's look at the cosine at 0 degrees. The adjacent side is almost equal to the hypotenuse. So that, at the extreme, would be 1 over 1, or 1. Make sense? See, I'm using this little triangle to help me imagine what it would be. Tangent, I don't even need to calculate because I can just say that tangent is equal to sine over cosine. I proved that on the other page. So that would be, in this case, equal to 0 over 1 or 0. So at 0 degrees, sine is 0, cosine is 1, and tangent is also 0. Okay? So what we can do is we can write on our unit circle right here, sine equals 0, cosine equals 1, tangent equals 0. This is like our summary page. We're going to go through and calculate for the other ones and then bring it back to this one so you can see. Let's do it at 90 degrees. I'm going to draw a fresh picture. I guess I should check and make sure. Not too bad. Okay, so here we are. We're going to be at 90 degrees now, which means that our triangle looks kind of like this, right? Our hypotenuse is approaching 90 degrees. This is equal to 1, right? And we're just imagining what's going to happen to our sine at 90 degrees, our cosine at 90 degrees, and our tangent at 90 degrees. At 90 degrees, we're right here, so the opposite side is going to be 1. The hypotenuse is 1, of course. The hypotenuse is always equal to 1 in our unit circle. Okay, so this time, we don't have much of the adjacent. It's the opposite side that's very close to being 1. So cosine is going to be equal to 0. It's going to approach 0, right? And then our tangent, which we said is equal to sine over cosine, we proved that right here, right? That is going to be 1 over 0, but look, kingdom explodes. So this, we say, is undefined. All right, so by imagining this triangle as we get close, as the hypotenuse gets closer and closer to this 90-degree marker, our sine and cosine are going to approach these limits. Okay, so at 90 degrees, sine is equal to 1, cosine is equal to 0, and tangent is undefined. Let's add those to our main chart up here. I'll write them up here. Sine equals 1, cosine equals 0, and tangent is undefined because we blew it up with that 0. All right, so this is at 90 degrees. This is at 0 degrees. Now let's look at 180. I'll do it on this same picture. I'll just use a different color so that you can tell. Okay, when we approach 180, our triangle's gonna look kind of like this, isn't it? Right? And we'll be here, and the sine of 180, that's the opposite side. That's gonna be the tiny side again, right? So that's gonna equal 0 over our hypotenuse of 1. The cosine of 180 is going to be this long length, right? It's going to be 1 because it's going to be very close to the length of the hypotenuse. They're going to touch up, right? But it's going to be -1 because we learned that cosine is negative over here, right? So it's going to be -1 over 1, or -1. And then tangent is equal to sine over cosine. So that's going to be, it's 0 over -1, which is equal to 0. So these are the values in purple for 180, right? If this is a little confusing, hang in there. We're going to use it a lot and it'll make more sense. So I'm going to copy these over. Here at 180, sine is 0, cosine is -1, and tangent is 0. And now we just have to do 270 down here. And I'll do those in, let's do blue. And that's gonna look like this. Our hypotenuse will be very close to this. And there'll be our right angle. And so 270 is the blue. And we'll have sine of 270, cosine of 270, and tangent of 270. Sine is, we're here, it's the opposite. Now that's going to be really long, right? The opposite side is what's close to the hypotenuse, so that's going to be really long, but sine is going to be negative, right? Because we're down here. Hypotenuse is still 1. Cosine, that's the adjacent piece, that's going to be tiny, so that's approaching 0. So that's -1, that's 0. Tangent, again, sine over cosine, so it's -1 over 0, oops, undefined. So here are the values for 270 that I'm going to add to the front chart. -1, 0, undefined. Sine is -1, cosine is 0, tangent equals undefined. And these are the values for 270. Now this is a little messy. We're going to do this again and again. Again, we're going to have other values that we're going to add within the quadrants. We're just getting the corners, if you will. Corners of a circle is not really a thing, but you see what I mean. We're getting the quadrants, the angles at the quadrants. We're figuring those out first. So what this does, it allows us to do calculations on 0 degrees, 90 degrees, 180 degrees, and 270 based on these values. Once again, we don't need calculators. We can use these values to solve some problems, and we're going to do that in just a minute. But what I want to show you is, yes, we're gonna memorize this. We're going to get a unit circle worksheet, and we're going to practice putting in values for these different points that we're going to be working with. Again, the unit circle is the idea that we can take the hypotenuse of our triangle and spin it around to any location we want here and find some cool patterns with the trig functions at those different points. but the quadrantal angles are where we're starting. And what I want to do is I want you to be comfortable with this format, but I'm going to teach you another quick reference that you can memorize to help you get those quadrantal angles down as an alternative to this unit circle. So let me show you what that looks like. It will help you notice the patterns. And like I said, we're going to be building on this for quite some time so that it'll make more sense as we go. Sine, cosine, and tangent. John tends to play with this and mix it up and put cosine first sometimes. I don't like to do that. I always leave them the same. So this is our chart of quadrantal angles. Draw it with me. And we're going to divide this into 4 columns. And what we're going to do is have 0 degrees, 90 degrees, 180, and 270. We just figured out the values for each trig function at each of these angles. We wrote them on the original circle. What I'm going to do is gather them up and just summarize them on this chart so you can see the patterns. At 0 degrees, that is the value of each of the trig functions. We figured it out. 0, 1, 0, 0, 1, 0. I'm just summarizing it all right here. 90 degrees is 1, 0, undefined. At 180, it's 0 minus 1, 0. And at 270, it's minus 1, 0, undefined. Okay, so this is just copying it. But what I want you to notice is the pattern that each function makes. Sine starts at 0, it goes up to 1, then it goes down to 0, and then it goes all the way down to minus 1. And if you repeat the circle, if you will, and you come back around, then it would be at 0 again. Okay? So there's a pattern and a flow that these make. And later we're going to look at these. They actually make curves. So we're going to look at that later, and this pattern will come back. Cosine starts high. Cosine starts at 1, then it goes down to 0, then all the way down to minus 1, and then back up to 0. And if we went back to a 360-degree angle, we'd be back at 1 again. So again, it's making a pattern. It's making a wave. It starts high, goes low. See, this one goes like this. It goes up, back, down, and then it would go back to 0, right, if we did it again. This one starts high, goes down, bottoms out, and then comes up. And then it would go up to the top again if we did one more. Okay? These we're going to get to later, and it's really fun how it all comes together. Tangent is a little weirdo. It kind of follows along. It's got the same zeros as sine, but then it's got these weird undefines, because when cosine goes to 0, that makes tangent undefined. So, like I said, we're going to memorize this, but for starters, a lot of students find it's more manageable to just take the information in a more condensed version and work with this. So let's figure out how we're going to use this. Example 29.1. If you're a little confused, it's okay. This is a lot. Draw figures as necessary to find 3 times the tangent of 180 degrees. Okay, so what John's asking us to do is he's saying, don't just look at your table and find the tangent of 180 degrees, which we see is 0. Try and draw it again. Okay, we'll do that because John's our friend. 180 degrees is this one, right? This is the 180. And so when we try to draw this little angle, we know it's like this. Our hypotenuse is almost to this line here, to this quadrant. And so if we stand here and try to figure out, okay, tangent, again, is opposite over adjacent, or sine over cosine. We can look at it either way. This time it's more convenient to look at it this way, right? Because we haven't figured out sine and cosine here. So let's see. If we're standing here, the opposite one is going to be 0, and the adjacent one is going to be close to 1. So tangent at 180 degrees is 0. We figured it out from the picture, and then we double checked. Tangent at 180 is 0. Okay, we did it right. So when we plug it in, it's 3 times 0. So our final answer is 0. Oh, do you feel smart? You should. This is serious trig business. Let's do a little more. Example 29.2. Draw figures as necessary to find, oh, this is one of these cheater ones. John just sometimes puts 2 problems into one and pretends, he acts all innocent about it, right? 4 times the sine of 270 degrees is our first one. And then the second part is 3 times the tangent of 270. So we won't rely on our chart. We'll check our answers with that, but we'll try to draw the pictures again. And I'll remind you of how we do that. 270, okay, so that means we're down here near the bottom. What we do when we're trying to draw these triangles is we think, let's put the hypotenuse of our triangle really, really close to the quadrant marker, right? So our hypotenuse is almost there, but not quite, all right? We're approximating. And it's like that, right? It comes out of the origin and then it goes back up. So this hypotenuse is very close to this, and its measure is 1, right? The length of this is 1, the hypotenuse. The hypotenuse and this marker is at 1. Okay, so sine is Oscar had. So we're standing here and we're trying to see what's the length of the opposite side. Is it 0 or is it 1? Well, it's going to be 1, right? Because the opposite side is almost the same as the hypotenuse. But it's down here, so we know that it's -1 over 1, right? The sine is negative because it's below the axis. Hypotenuse is always positive, and that's 1. So the sine of 270 degrees is -1. And then we check our chart. There it is. Yay, we got it right. And now we just multiply it by 4 equals -4. Make sense? Let me just double check, make sure I got it right. Yay. Okay, good. So now that we've got the first part done, now we're ready to do the tangent. Okay, and we can see that if this one we won't rely on sine over cosine, we'll just do like we did over here, we'll do it as over Arthur. Since we calculated sine, but we didn't calculate cosine, so we'll just start from the beginning. If we're here, the opposite side is -1, and the adjacent side, that's the one that's disappearing, so that's going to be 0. Oops. Tangent at 270 degrees is undefined. So 3 times the tangent at 270 is also undefined. That squares with what our chart says, and John believes it too. Okay? So we got those both, right? Okay. Flipping over here. And there's just one more problem. Example 29.3. Evaluate. Okay, now this is getting a little bit wackier. Okay. Oh, you guys, we're really getting into the juiciness of trig now. All right, this one is adding. Now, this one looks good to me because I see 180. That's one of our quadrilateral values. I'm good with it. It's the chart. It's drawing the little triangle on the unit circle that's really, really close to the quadrant marker, even though it's not. We draw it as if it were a separate triangle, but we're really just trying to see what it's going to happen to it. This is not one of those. 135 negative is not a quadrilateral angle. But I go, wait a minute. This is minus 135. It's 90 plus 45. It's this angle, isn't it? Right? This is minus 135. And so this is 45. So that means this is a 45-45 reference triangle. Now you guys that we've been doing the reference triangles for a while, I will show you that I don't draw them separately anymore. I just draw them right into the main part of the diagram. So I've identified this as a 45-45. So now I'm going to go 1 square root of 2. I want the sine of 135 degrees. That is going to be, sine is Oscar had, so it's 1 over the hypotenuse, square root of 2, but sine down here in this quadrant is negative, isn't it? Because I'm down below this. So it's negative 1 times the square root of 2. We don't have to do anything, we don't have anything to multiply that by, but I want to rationalize it. And what I'm going to do is I'm going to put like a little marker here. So this is my work on this side, and then that'll be my work on this side. So the sine of minus 135 degrees, I go over here, I find this triangle, I pull the values. I don't have to multiply it by anything. It's good just like this. But I want to rationalize my denominator, so it's minus square root of 2 over 2. I did that in my head, like so. Okay, so this is the first part of my answer, and then I want to add, because there's add, 3 times the square root of 2 times the cosine of 180. So now I need to draw the picture that's going to show me the cosine at 180 degrees. So here is this. This is my 180 degree marker. I want to draw the hypotenuse as it's almost there. That's going to look like that. Cosine is a hold. So I know the hypotenuse is going to be equal to 1 because on the unit circle it's always 1. Now the adjacent side, I'm here. So the adjacent side is the one that's approaching the hypotenuse. So that's going to be 1. But I'm on this side of the axis, so it's going to be negative 1. So the cosine of 180 equals negative 1. And just to make sure, I can check my chart, cosine of 180, oh, negative 1. I figured it out, right? I got it right. So that's exactly the way I want you to work these, you guys. I want you to have that chart handy, but I want you to struggle with the diagrams and try to figure out how you can wrap your head around this concept of there isn't an angle right at 180 degrees, but what if we drew one that's really close? Then we can figure out which side is approaching 0 and which side is approaching 1. Okay, so the cosine of 180 is minus 1, and so we just have to multiply it times 3 square root of 2, so this is going to be minus 3 square root of 2. Okay. Now I have my two parts together. This is looking decent, but in order to combine these, I have to have the same denominator. The radicals match. I'm excited about that. But we're going to have to multiply this one by 2 over 2, aren't we? It's over 1 now. That will give me the denominator of 2. So I'm going to write minus square root of 2 over 2. I'm going to skip this because I have a minus sign there. So I'm just going to do minus 6 square root of 2 over 2. I'm multiplying this times that, right? Wolf times wolf, pig times pig. All right, I've got matching radicals. I've got matching denominators. Hallelujah. But how do I subtract that? I remember that this is a minus 1. So minus 1 square root of 2 minus 6 more equals minus 7 times the square root of 2 over 2. That is, oh my gosh, you guys. That is the value of combining these two trig functions at different angles, right? So just think of what we did. We found the sine of this angle, and then we found the cosine of this angle, multiplied it, and then we added them together. Now, here's the question. Why would you want to do that? Why? You have to go to college to get the answer to that question, my friends. I don't have an answer for you in this book, but if you go on to calculus, you will understand why. So we're learning to manipulate and understand kind of the basic ideas here. We know what a trig function is. We know that it's a ratio of the sides. We know that we can memorize these different devices and do the calculations, but we really don't understand quite why. It's kind of theoretical at this point, but we can live with it. Our special triangles are 45, 45, 90, and our 30, 60, 90. They are going to be the friends that we will eventually add to this diagram. All right? It's going to be so fun. We're going to just get all of this information into one big diagram. And we've started by getting these corner points again, if you will. All right? And we see the way that the values of these trig functions fluctuate, right? They never go higher than 1. Well, sine and cosine. They never go higher than 1, and they never go lower than minus 1. They modulate between those two extremes, and that's what these values help us see. That's the highest, that's the lowest. That's the highest, that's the lowest. Tangent doesn't follow quite the same pattern because it has these funny undefined pieces. We'll talk more about that later in the year, all right? So we're going to come back to this. So that was a lot to swallow. I hope it makes sense to you. We'll talk about it in the video chat this week, and reach out to me sooner if it's more than your brain can handle. Thank you. Bye.